Okay, this video is all about triangles. Okay, as it says, introduction notes. So this is the first time you've seen triangles since probably junior high, which means you remember everything.
Students, if you're a bus rider, you need
And
to
there's
head
McKenna.
straight to the bus
Thanks,
route.
McKenna.
All buses are on campus and will be leaving shortly. There is no loitering in the halls after school. You must keep moving.
Don't loiter in the halls. Anyway, so we can classify triangles by the amount of sides it has, right? Equal sides. So if it has no equal sides, we call this a scalene triangle. Okay, scalene has no congruent sides. Two congruent sides is an isosceles triangle, and three congruent sides is an equilateral triangle. Okay, equilateral, equal sides. Lateral stands for sides. So you have no sides, right? Scalene, all different sides. Two congruent sides are isosceles. Three sides are equilaterals. Okay, or we can classify them by their angles. If all angles are less than 90, we have an acute triangle. Acute. If one angle is 90 degrees, then it is a right triangle. And if one angle is between 90 and 180, we have an obtuse triangle. So we can combine any one of these. We can have an acute isosceles, or we can have an obtuse scalene, or we can have a right equilateral. No, we actually can't. We can have a right isosceles triangle. Equilateral is always going to be acute. Okay, we don't have to call it acute because all the angles are less than 60. Or all the angles are equal to 60. So moving on here, the triangle angle sum theorem says that if we add up the three sides, or rather the three angles of your triangle, that sum is going to be equal to 180. That's an 8. I want it to be a B. See what happens when I talk and write at the same time. Measure of angle B plus the measure of angle C equals 180 degrees. Okay, as I add up all these angles, they equal 180. All three of them. You probably have recognized that from junior high. Okay, something that you might not recognize is this thing called the inequality theorem, okay, which says that in a triangle, any two sides have to add up to be bigger than the third side. Okay, so you take any two numbers and add them, and it has to be bigger than the third side. So maybe A plus B, or A plus C, or B plus C. It does not matter which two sides you pick. Any two sides have to add up to be bigger than that third side. Okay, so here I'm giving you two possible sides. So let's watch this movement real quick here. So I have myself a triangle. Okay, and this side is 4 units long, and this side is 10 units. Okay, so like we had a second ago over there, we know what side 1 is, and we know what the second side is. So we're asked for the third side. Okay, what's the range of the third side? That we don't know. So side 1 is 4 and side 2 is 10. Okay, now remember, these two sides, the two smaller sides, have to add up to be bigger than the third side. So this is the measure of this third side, by the way. Right now it's 7.49 when this one is 4 and this one is 10. So as I bring point E closer to my 10 centimeters, notice this length here gets shorter, okay, as it should, because we're getting closer and closer and closer to this. Eventually, it looks like we will get two exactly, right, a straight line. Okay, and if it's a straight line, then we don't have a triangle, we have two straight lines. So the shortest this could possibly be and make a triangle looks like it's going to be 6. Okay, 6 is the smallest this side could be. So it could be 6, right, as the smallest value. So as I continue moving this up, though, right, as I move it up and away, now it gets to be 7, and now it's 8, and now it's 9 and 10, and I still have a triangle. Okay, and now EF is the largest side. Okay, so then 10 plus 14, right, how big can it possibly be? It looks like it's almost up here, really, really close to 14. And when it gets to 14, it's exactly straight, and we no longer have a triangle. Okay, so we have a range of values. It has to be greater than 6, right? Because if it is equal to 6, then we have two equal sides, and it has to be less than 14. Okay, 14 is the largest or the upper bound. So the range is anywhere between 6 and 14. So 6 is less than that third side, which I guess is EF, which is less than 14. Okay, not equal to, because if it's equal to, then you have two of the same lengths. So if we notice 4 and 10, what operation do we perform on 4 and 10 to get 6? Well, that's a subtraction problem. So if you want to find the smallest possible length, we're going to subtract those two values. And then for 10 and 4 to get 14, we add them. So if we add them together, that will give us the maximum value for the longest length. So anywhere between 6 and 14 is going to be fine for the length of this triangle. So coming back over here, okay, if I had a side of 8 and a side of 10, then the smallest it could possibly be is 2, right? It has to be bigger than 2, 2.01, 2.02, whatever. And the largest this could possibly be is adding them together. So 18, right? 17.9, 17.99, which is why we have a strictly less than sign here. Okay, 16 and 7, if we subtract them, we get a side length of 1 as the smallest possible. And if we add them together, it cannot be any bigger than 33. So the range of values, right, the possible third side length can be anything in between these two numbers. Ooh, 9 and 9, 0? Could we possibly have a side length of 0? No, we can't. It has to be bigger than 0, which is why we have the bigger than symbol. And it has to be less than 18. Okay, so to get the smallest number, we subtract. And to get the largest number, we add the two numbers that were given together. Okay, and that gives us the range of the third side, anything between 2 and 18. It could be 9 or 5 or 17 or 12 and a half, whatever. It gives you a range. So we want to write down the minimum, right, the smallest possible, and write down the maximum, the biggest possible. Okay, and then there's a relationship here between the sides and the angles. If we noticed over here, okay, make this go away. Okay, when this is a big side, right, when 12.61 is the largest side, that means that this angle here is the biggest angle, right? This looks like it's the largest angle. It's clearly obtuse. Okay, is there. But notice where the smallest side, if this is the smallest side, then the angle across here is the smallest angle. So we find that the biggest side is always across from the biggest angle, and the smallest side is across from the smallest angle. Okay, that's the relationship between the sides and the angles. The largest angle is across from or opposite the largest side, and vice versa. Okay, the largest side is across from the largest angle. Okay, same thing for the smallest in the middle. They all are across from the one that they relate to. So if we're going to list the angles in ascending order, that means from smallest to largest. Okay, ascending, going up. We start by identifying the smallest side. So if BC is the smallest side, that means angle A is the smallest angle. Okay, and then we have 11 is the next smallest, so the medium, which means angle C is the next largest angle. And finally, we end with 15, the largest side, which means angle B has to be the largest angle. So A is smallest, C is middle, and B is biggest. Okay, and that goes the same thing for side lengths. Okay, less the sides. So for the sides, we're going to use two letters. L-E-T-T, two letters for sides. So this is clearly the smallest angle. So the side is this one here, HK. So HK is the smallest side. No, it's not. Look at this. 20 degrees is much smaller. 20 is smaller than 37. So actually, it looks like HJ is the smallest side. And then HK is the middle, right? It's between these two. And then clearly, I say clearly, a JK is the largest side because it's across from the largest angle. So we always use 2 letters to write sides, and we use 1 letter to write angles. Okay, it's the easiest way to do it.